On this question, we want to graph the following inequality. Y is less than or equal to 7/4 x plus 3. When we graph an inequality in two variables, we need to do that in two parts. We start off by graphing the boundary. And the boundary is the inequality changing the less than or equal to sign to an equal sign. So the boundary line is y equals 7/4 x plus 3. Now, when we draw the boundary line, we need to decide whether we're going to include the points on the boundary line or not include the boundary points. So we can tell whether to include or not include based on whether we have this equal sign here. When we have that equal sign, the boundary line is part of the solution. So we would draw it with a solid line so that we include those boundary points. So this particular boundary line is y equals 7/4 x plus 3. And we want to draw that line. It's in slope-intercept form, y equals mx plus b. So I can start by plotting the y-intercept, which is 0, 3. And then I can use the slope, which is 7/4, as rise over run to get me to a second point on the line. So let's plot 0, 3, and then use the slope to get to another point. We'll rise 7 and run 4. That gets me to a second point on the line. And we're going to draw that boundary line as a solid line because the boundary line is included. So after we've drawn that boundary line, then we want to do the second part of graphing the inequality, which is the shading. So when we do the shading, what's happening is we've drawn that boundary line, and that boundary line divides up the region, divides up the plane into two parts, above the line and below the line. And we're going to shade one of those sides. One of those sides are solutions, and we need to decide which one is a solution. So in order to decide which one is a solution, we need to pick a test point. And the only rule with the test point is that it cannot be on the line. So we can pick any ordered pair that's not on the line. Most people like to choose 0, 0 as the test point because it makes all the math work out nicely. So I'm going to substitute this test point into that original inequality. That's y is less than or equal to 7/4 times 0 plus 3. And when we simplify, we get 0 is less than or equal to 3. This is a true statement. So the test point that I chose is below the line, and it came out true. So what that tells me is that all the points that are below the line will also be true. So I'm going to shade that side that contains the test point. So the boundary line and all of the points below the boundary line are part of the solution set. All of these points make that inequality true. For this question, we want to graph the system of linear inequalities in two variables. We have the system of x plus y is greater than or equal to 6, and 2x minus y is less than or equal to 4. So when we graph a system, we're going to graph each inequality in the same coordinate plane. So let's start with the inequality x plus y is greater than or equal to 6. We'll start by graphing the boundary line. So I'll label that with B as boundary. And the boundary line will be x plus y equals 6. I replace the inequality symbol with an equal symbol. Since our inequality has the equal to, we will draw our boundary line as a solid line, and the solid line indicates that the points that are on the boundary are included in the solution set. So this particular equation is written x plus y equals 6, so I can easily find the x-intercept. Find the x-intercept by letting y equal 0. That would give x plus 0 equals 6, x equals 6. So we have 6, 0 as the x-intercept. We can find the y-intercept by letting x equal 0. That gives 0 plus 6 equals 6. Excuse me, that's 0 plus y equals 6. And we get y equals 6. We have 0, 6 as our y-intercept. I'll plot those 2 points, 0, 6 and 6, 0. Connect those 2 points with a straight line, a solid line. Alright, looks good. Alright, let's try that again. My ruler moved on me. Alright, we're going to forget the ruler and we'll just make it sloppy. Okay, so we've got our straight line, a solid line, and we need to figure out which side to shade on. So then we're going to find our test point. The test point cannot be on the line, so we'll use the point 0, 0. We'll test that into our inequality. 0 plus 0 is greater than or equal to 6. That simplifies to be 0 is greater than or equal to 6. And that is false. So our test point is below the line, and it came out false. So I know to shade the other side of the line. So the ordered pairs that we see in the shaded region and along the boundary are going to make the first inequality true. So now we're going to do the same thing with the second inequality. For the second inequality, we have 2x minus y is less than or equal to 4. We're going to graph our boundary line, which is 2x minus y equals 4. And this time I'll use a different method for graphing the line. I'll write this in slope-intercept form. So I'm going to subtract 2x, and we get negative y equals negative 2x plus 4. Divide by negative 1, and we have y equals 2x minus 4. So in slope-intercept form, I can see that I have a y-intercept of 0, negative 4, and a slope of 2, which I'll write as 2 over 1, and that's my rise over run. So we have our y-intercept at negative 4. I'll rise 2 and run 1 to get to a second point. And thank you for the compliment about drawing a straight line. We'll try it again. And I kind of skipped a step there. I didn't mention about drawing a solid line, but at the same reasoning that we had before, because our inequality symbol includes the equal to, that's why we're drawing a solid line. So this line divides up the coordinate plane into 2 sides. We need to figure out which side is the true side. So I'll choose my test point again. Let's choose 0, 0 as the test point. and we'll substitute it into our inequality. That's 2 times 0 minus y, 2 times 0 minus 0 is less than or equal to 4, and that simplifies to be 0 is less than or equal to 4, which is a true statement. So this time our test point of 0, 0 came out to be true, and it's above the line, so we're going to shade above the line. Let me choose a different color here so we can distinguish it. So I'm shading above the line. And all the points, all the ordered pairs that are shaded in green and the ordered pairs that are on that boundary line make the second inequality true. So finally, we need to think about the solution to the system. A solution to a system are going to be ordered pairs that make both inequalities true. So in our picture, we have this region here. You can see that it is shaded in both green and the orangey color. And so these ordered pairs are solutions to both both inequalities. And we're going to include the points on this boundary line and the points on this boundary line, only these sections. So this region, including the boundary lines, are solutions to the system. So on this first question, we are trying to evaluate g of f of -1. This is called the composition of functions when you substitute one function inside of another function. We're trying to do this evaluation using the picture that you see on the right. So you can see that this graph, this first curvy one, is labeled y equals g of x. So these are the points that are on the graph of g of x. And then we also have y equals f of x labeled, and these are the points on the graph of f of x. So when we evaluate this composition of functions, we start on the inside. You can think of it as order of operations. We're going to do the inside first. So we need to know what f of -1 is. So f of -1, this notation is looking for the y coordinate. -1 is the x coordinate, and we're looking for the y coordinate. I have an x of -1 right here. This is on the graph of f, so that's a -1, 0. And so f of -1 is equal to 0. So I'm going to replace that inside part of f of -1 with 0. We would write g of 0. So we're going to continue on now finding g of 0. To find g of 0, this notation, once again, means that we're looking for y. 0 is the x, and we're looking for the y on the graph of g. So looking on the graph of g, having an x of 0 would be this point right here. That's the ordered pair 0, 7 on the graph of g. So g of 0 is equal to 7. So we found the answer to g of f of -1, and that's 7. Okay, so in part B, we now want to find f of 0. So once again, we're going to start with the inside part, the f of 0, and looking here on the graph of f, here is a point that has an x-coordinate of 0, and that has a y-coordinate of -1. So I know that f of 0 is the y-coordinate of -1. Now replace that f of 0 with -1. f of 0 is -1, and now I want to evaluate f of -1. Now we did this a little bit earlier, so I'm going to use my work from earlier. F of -1 is 0. So we're using this ordered pair right here. F of -1 is 0. So we found f of 0 to be 0. On this next part, we want to find f of g of -1. So starting on the inside, we'll find g of -1. So I'm looking on the graph of g, and g of -1. G of -1 would be here, and that is the ordered pair -1, 5. And I'm just noticing that on that last example, I misspoke, so I just want to correct myself. I was not using this point right here. I was using f. Oh, I was using that point. Okay, sorry about that. All right, I didn't misspeak. Okay, so g of -1 is 0. Now I did misspeak. G of -1 is 5. G of -1 is 5. F of 5. So f of 5, I need to go to the graph of f with an x value of 5 right here. That's the ordered pair 5, 2. We want the y coordinate, which is 2. So f of g of -1 is 2. So g of 4 is the next part. So we'll start with the inside, g of 4. So looking on the graph of g, here we have an x coordinate of 4 with a y coordinate of 4 as well. So g of 4 is 4. And g of 4 is 4 again. So we have g of 4 being 4. So in part E, we have f of g of f of 0. So starting on the inside, we want to find f of 0. F of 0 is right here, which is -1. So this gives f of g of -1. So then we want to find g of -1. G of -1 is here, which has a y value of 5. That's f of 5. And then f of 5, that will be right here. F of 5 is 2. So in part F, we want to find g of f of g of 4. So we need to find g of 4. G of 4 is right here, which is 4. That gives g of f of 4. We need f of 4. F of 4 would be right here. That's the ordered pair 4, 1. So f of 4 is 1. G of 1. And g of 1 is right here. 1, 6. So g of 1 is 6. So I have this picture here, and this picture comes from a homework question, which is asking about the relative minimum and the relative maximum. And this can be a little bit confusing because if we're only thinking about the words minimum and maximum, you would think that you're looking for the highest or the lowest. And The problem is that word relative that's in front of it means something different than just the highest and the lowest. When we have that word relative, what we're looking for is if we're able to look in a localized area, is there a maximum or a minimum value? So if we were looking on the whole graph, we would say that this y value is the largest, which is a max, and this y value is the lowest, which is a min. But we need to find a relative min or a relative max, and a relative min and max need to have a neighborhood nearby where it's the maximum or the minimum. And actually the definition that your book gives is a little bit different. The definition that your book gives for a relative max and min involves increasing and decreasing, or a change in increasing and decreasing. So the way that your book defines the relative min is that you should see a change from decreasing to increasing in the graph. So if we look right here, on the left-hand side of this point, the graph is decreasing, and on the right-hand side of this point, the graph is increasing. So this point right here creates a relative minimum. And then for the definition of a relative maximum, your book uses the definition of change from increasing to decreasing. So right here, up to the left of this point, we have increasing in the graph, and to the right we have decreasing. So this point right here would be a relative maximum. So if you're looking for relative minimums and maximums, you're looking for these little peaks and valleys in the graph. So we would say that this particular graph has a relative minimum of -16, which occurs at x equals -4. And it has a relative maximum of 16, which occurs at x equals 4. Thank you for checking out my videos. Have a great day.